So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. This week, we're talking about the practical aspects of installing heat pump systems. Now, there's a lot of companies that are manufacturing heat pumps, but for electrification, high efficiency and flexibility are critical parameters. So, replacing that old gas furnace with a heat pump, which we call a retrofit, it's trickier to do in many cases than for a new construction installation. So my guest on this week's show is Dennis Stinson. Dennis is the VP of Sales at Fujitsu General America. He's been in the heat pump business for almost 30 years. He's based in Pine Brook, New Jersey, my old stomping grounds. Now, I've been really impressed with Fujitsu's high-efficiency product line. It's a really good fit for people who are electrifying their homes. So welcome to the show, Dennis.
Thank you, Barry. Thanks for having us. Looking forward to the conversation.
All right, let's dive right in. Tell me a little bit more about Fujitsu's heat pump business, please.
So Fujitsu is Japanese-based. So we are originally formed in Kawasaki, Japan, and really a world leader in heat pump technology. So we were one of the first to start working with inverter technologies, one of the first to start working with 410A. That's all we do is manufacture heat pumps. So we make both residential products and commercial products and single zone and multi-zone products. So our product offering is available in 60 countries around the globe, one of 17 subsidiaries. And it gives us just a great offering and great solutions for consumers and businesses alike.
It's interesting that Fujitsu's making these mini split systems for many, many years. And we're finally coming around to a situation where as we electrify existing homes and businesses, that equipment is really ideal. The old way of making heat pumps with one big compressor and powering a huge fan or blower, it's not really giving people the efficiency they need. So I really like some of the technology you guys have. So what are some of the different designs of heat pump systems that Fujitsu has?
Well, so we offer a variety, and our industry offers a variety. So if you think of it this way, a heat pump is what we learned in sixth grade physics, right? So we're taking a refrigerant, and we know if we change the state of refrigerant, we change energy. So if we change pressure, we change temperature. And really what a heat pump is, it's a lack of cool air. So what it does is a heat pump is taking heat out of the outside in the wintertime and moving it to the inside. And in the summertime, it doesn't produce cold air, but it creates a lack of warm air on the inside and takes it to the outside. So that's really what a heat pump is. What we're doing is moving refrigerant from an outdoor unit to an indoor unit, and we're moving air across that. So we're creating good, strong comfort on the inside, whether we're in heating mode or in cooling mode. Now, we offer a couple of different types to do that. We can do that inducted or non-ducted. So if the consumer prefers, or the commercial property owner prefers, grills and registers and diffusers, we can do that. If you prefer to have an evaporator in the space, and be that wall mount or ceiling cassette or floor mounted product, we can do that as well. The best thing about this technology, Barry, is that it gives you tremendous options on how to condition a space.
That makes total sense. We're talking about a lot of customers here in California who have an existing furnace, and they might have a 2-story house or, a ranch house with different sections, and really having that flexibility is important. I got to back up to one thing though. Mm-hmm. When I went to school in 6th grade, 10 miles from your headquarters, we didn't really get into the physics of heat pumps, but that was an advanced college engineering course. But yeah, I'm talking to a lot of engineers out here, and it is kind of fascinating to see all the advances that have been made in refrigeration systems. Even when you buy an EV, a lot of the electric vehicles, they don't have just resistance heating. They have heat pumps that are actually warming and cooling the car cabin.
Yeah, it just makes a lot of sense. I mean, so you have to transfer the heat or the cooling in one form or another. So the main difference between a typical unitary type system, which is where you have an outdoor unit, you have an air handler at some point in the property, whether that's in the basement on the East Coast or the attic on the West Coast, and then you distribute the heating and cooling throughout the house through ductwork. What we're doing is we're putting an evaporator at the point of use. So we are eliminating the loss, and there is a loss in temperature change through the ductwork. If we listen to our industry standards, which is ASHRAE, they would tell us that we should expect up to 30% loss through our ductwork. So if we're running ductwork through our attic and our basement, then it's an unconditioned space. Even if we condition that between duct lossage and leakage and temperature change, we can lose a fair amount of efficiency through that. So by being able to put the evaporator in the space or the point of use, then we preserve that efficiency, if you will. So just that basic mindset kind of brings a better understanding to what we're doing.
Yeah, we were discussing that at one of our sales meetings this morning is, you kind of look at systems based on the seasonal energy efficiency rating and, the higher the better. But then you may have the same SEER rating for a ducted versus a ductless system, but the ductless system, since it can be zoned also, is going to give you better efficiency.
Absolutely. Absolutely.
All right. Well, I often see this indoor, I call it an air handling unit because I might be a little bit old school, or head unit hanging from the ceiling, and it's kind of in the living space. Is there a way to hide that unit to make it less obtrusive?
So you're referring to the wall mount unit. So this would be a horizontal unit. It's rectangular in shape. And that is by far the most popular indoor air handler that we sell. Overall volume, that is by far the most popular in our industry. And it's done that way because it works really, really well. Installation is pretty simple to do. I mean, we're looking at a 3.5-inch hole in the wall to be able to run our line sets or refrigerant piping and our wiring to the outdoor unit. And it also gives great throw. I mean, we're capable of throwing air 27 feet across the room, so we can cover most rooms to be able to do that. But that being said, you do get into some properties where people say, you know what, I have a historic house or I have design in my house. I may not want to see that on my wall. And if that's the case, then we have the floor mounted console. And being from the East Coast, that would remind you of our radiators, right? So if you're used to something underneath of your window, then that would be very along that line, or you're doing a knee wall in a sunroom, then it keeps it down low and be able to do that. We also have ceiling cassettes, and these are 2x2, and they would recess up into a ceiling. So if you're pulling a ceiling fan out of a room, and you can now because you're taking in air conditioning and heating into it, if you choose to pull out the ceiling fan, then all of your HVAC is being distributed from the roof in a recessed grid that is not obtrusive at all. And then, as I alluded to before, we also have ducted units. So even though I call myself a ductless company, we do have ducted units, and we make a couple of different flavors in, low static, medium static, and high static. But what that really means, Barry, is if somebody wants to see grills and registers and diffusers and wants to be traditional, you can have the best of both worlds. And that is, you can have the look of a traditional system, but still be zoned and still be high efficiency and still be inverter throughout your property. So to answer your question, we got a couple of different choices to be able to address that.
I was just thinking about when we renovated the building, the commercial building that our office is here in Los Gatos, and it was complete renovation. We put in 6 rooftop heat pump units, and we looked at ductwork that had dampers in them so we could zone. And I guess that's kind of old school. That's one way of doing it. But, it's nicer if you could just put these little cassette units into different rooms, and then you're going to get a heck of a lot better efficiency and reliability, and you don't have to worry about fan speeds that may be overwhelming or not enough to push enough air around the building.
Yeah, and it depends, and I'm not telling you anything. It depends on when you look at a zone system, and they are good. When you look at a zone system, if it's not a communicating inverter, then what happens is you have a single speed output on it. And what that means is if you have only a small zone calling, you're still using the full capacity of the system. And then somewhere you have to be able to dump or return or spill that excess velocity back into the system. So there's some inefficiencies created with that. Really, what I like best about the zoning is not only is it zoned. So if I'm downstairs watching the game at nighttime, I don't need to condition my bedroom because I'm going to be downstairs for a couple hours. So I can turn that temperature on and get that comfortable where I need. If my kids are off at university and they're not occupying their rooms, I don't need to keep their rooms the same temperature as the rest of the house. I can keep it from freezing, but I don't have to keep it the same temperature. If when my kids are home, they like to sleep at 72 and I like to sleep at 68, everybody has their own individual remote control or thermostat, if you will, in that space So nobody is sweating and nobody is burying themselves in blankets because the thermostat's in the hall controlling the whole house. So the energy efficiency and the comfort level with zoning is really second to none.
Yeah, it makes a big difference. So these are all the enhancements that happen and that have happened in the industry over the past 30 or 40 years. So I was just thinking about the word variable. Imagine how inefficient your car would be if you couldn't vary the engine speed. It was either full speed on or full speed off. So to me, the word variable captures the reason why these newer design heat pumps from companies like Mitsubishi are so much better. You have variable speed compressors, you have variable refrigerant flow, you have variable fan speeds, and that just adds to the overall efficiency of the system. So kind of getting into that, you mentioned inverter, and I've been dealing with inverters for 25 years in the solar industry, but tell me how inverters work with a variable speed compressor in the heat pump compressor unit.
So it's really great stuff. So what we're doing is an inverter is a variable speed and it's converting AC to DC. And we convert to DC so that we can get a greater range of control. Instead of just using a frequency drive and dialing down something, with the DC, we get much, much greater control. And actually what we do with our compressor is we convert from AC to DC and then simulate three-phase electricity going into our compressor so that we can drive that compressor around and create tremendous efficiency. And we use a variety of scroll and rotary compressors, just some different technology to be able to do it. Some work better than other in different applications. So we vary on what we're doing there. But at the end of the day, what we're doing is we're variable speed. And by converting from AC to DC, so I'm adjusting the speed of my compressor based on what the demand is. So inside of the room, I have a thermistor. I'm measuring room temperature. I'm looking at what set temperature is. I'm looking at what outside temperature is. Then every time I change the state of refrigerant in all of my different spots, I'm also grabbing a temperature as well. So uniquely enough, not only am I just changing the speed of my compressor, I'm changing the speed of my indoor fan, my outdoor fan, my refrigerant metering device, and my compressor. So now if you want 68 degrees in the inside and it's 30 degrees outside, I can vary that, the flow of the air on the inside, the flow of the air across the coil on the outside, my refrigerant metering, so I can peg that temperature and just hold it steady. That's really what you find with inverter technology. You find a nice steady temperature rolling through there, and you find that your unit is always on at a very, very low speed, just producing air, replacing what temperature or thermal loss is happening through the building structure. So it's very comfortable. A traditional system that's on and off, you typically see a 4-degree temperature swing. So it comes on at 72, goes off at 68, and you're constantly swinging that temperature. Where with inverter, you're hitting that temperature and you're just snugging it right along.
Yeah, one of our executives, since we've been doing a lot of solar and starting to do electrification, he put in a heat pump about a year ago, and he worked with a company, and they said, we got a great deal for you. And he put this unit in, but it's not variable speed, and it's actually oversized. So when it goes on, it heats or cools the room really fast and makes a lot of noise. And then it goes off for a little while. And then it comes on and off and on and off. And it's driving them crazy. And then, we kind of dug into it and realized, well, the system's not variable speed. It's oversized and it doesn't have a really good efficiency. It's like, I should have learned a little bit more about this technology, because all heat pumps are not the same. It's really important to make sure you got the right kind of equipment.
No, you're exactly right. All heat pumps are not created equal. A gentleman on my team often says that. So that's a term that I listen to a lot. It's really a matter of being able to scrub the heat out and move it to the area that either you want it or the area you want to remove it from. And being able to vary fan speeds and flow of refrigerant and compressor speed, you can really dial that in and really chase crazy efficiencies on it.
Yeah, I put in a variable speed system at my house about 4 years ago. When we turned it on to test it, I didn't think it was working. It was silent. I kind of finally looked at it, got up near the vent, and there was some air coming out, and I realized, boy, the thing is, it just operates silently. The comfort's terrific, and I got an amazingly low utility bill now. All right, so when we were kind of getting ready for this show, you threw a TLA or a 3-letter acronym at me called VRF. What is VRF?
Yes. So VRF is variable refrigerant flow. So instead of all or nothing, variable refrigerant flow meters and measures the refrigerant throughout a system. And it typically refers to a commercial property, or commercial equipment. So we have a complete line of variable refrigerant flow product from 3 ton or 36,000 BTUs up to 16 ton. And we have the ability to to couple together our larger systems for even larger properties. So the offering that we have, we can go across many installations and many different indoor heads and variety. But again, the VRF technology is the technology that varying my compressor, I'm varying my metering device, I'm varying my fan speeds on indoor and outdoor. But on the commercial side, I'm also doing that through multiple heads as well. So I can have a building with 30 or 40 indoor heads, and I can have some of them working at a minimal capacity or a maximum capacity, and I'm varying the flow of refrigerant going in and out of that property. Now, what's kind of cool too is with VRF, I can also do, with the right equipment on the site, I can also do simultaneous heating and cooling. So if I have a property where all of the offices on the outside are getting sun exposure and they need cooling, but the center of the building isn't getting any sun or solar gain and need heating, then we have equipment that can do both heating and cooling at the same time. That works really well in multiple family housing. You could have somebody that's on the north side of the building that they're calling for a little heat. And you have somebody on the south side on the upper floor where it's a little warm and they're going to need some cooling up there. So VRF gives us the ability to be a straight heat pump or also be a heat recovery unit that can do heating and cooling at the same time.
That's pretty amazing. You mentioned tons and you mentioned BTU. How do those two terms equate?
Great question. So a BTU is a British thermal unit. And we know that 12,000 BTUs creates a ton of heating or cooling. So what we do is we do a heat loss on a property, a heat loss or a heat gain, depending upon whether you want to heat or cool. So staying in the heating side, we do a heat loss. We know that if we have a structure based on how many windows and the type of insulation, where it's located in the world and which way it's facing, north, south, east, or west, there's going to be an amount of heat that goes from the inside to the cooling outside, and that's called heat loss. In the summertime, it would be a heat gain. So just so we understand, hot goes to cold. So in the summertime, any solar gain on the outside would be coming to the inside, and we classify that as a heat gain. So we measure that based on all those variables and express that in BTUs or tons of heating or cooling needed in the heat pump world. So as a consumer, you would typically find that contractor would come out, would walk the site, do a heat loss and a heat gain because it's a heat pump, so you're going to need both. They'll do a heat loss, he or she will do heat loss and heat gain, and then recommend the equipment based on the performance of it to cover both sides of both the heating and cooling.
And that's something that a lot of our customers need. Now, fortunately, many of our customers are doing retrofits, so they have an existing air conditioning system and they know how many tons that was, and they have an existing furnace with a certain amount of BTU output. And then I guess it's just a matter for the heat pump company, for Fujitsu, to find a unit that provides that amount of heating and cooling.
Yeah, I would still recommend somebody do a heat loss and a heat gain. You really don't know if there's improvements to the property. Maybe the windows were upgraded, or maybe that something there has changed. And we also don't really know how well the original heat loss or heat gain was done. Sometimes, in all honesty, in the supply house business, what gets put in is what's in stock. And that may not necessarily be what they needed. So a good heat loss doesn't hurt.
Yeah, that definitely makes sense. If you match it more closely to the building's needs, you're going to operate more efficiently.
Absolutely.
All right, so speaking of efficiency, what are the measures of heat pump efficiency?
Well, there's two measures that we really go by. SEER, SEER, is Seasonal Energy Efficiency Rating, and that relates to the air conditioning side. The higher the number, the better. If we look at where we are today in the United States, today, roughly speaking, air conditioning installed in the South, the southern region of the United States, needs to be at least 14 SEER. Air conditioning installed in the northern part, if you basically look at the Mason-Dixon, the northern part would be 13 SEER. So where the demand is longer and stronger, we're looking for more efficient equipment to be able to be there. When we look at measurement of heat, we do that in an HSPF, and that's heating season performance factor is what that would relate to. And the higher the number, the better on that. And there's some requirements for that as well. So when we look at the north being 13 SEER and the south being 14 SEER for air conditioning side, a typical ductless heat pump like mine, my entry level is going to be 16 SEER. My highest SEER product is going to be 33. So the minimum efficiency ratings really mean nothing to a ductless company because we are light years ahead of what those requirements are.
And in terms of kind of looking at it as a rough efficiency measure, it doesn't equate to a normal system. Is it fair in a heating mode to assume that you're going to get a 300 or 400% efficiency, which is the heating output divided by the electricity input?
Yeah, so your COP is where that comes into play on that. And yes, heat pumps in general put out more energy in terms of heat than what they bring into, than what it takes to run it. And that's through the inverter technology and the VRF and how we handle the refrigerant. So roughly speaking, yes, you look at tremendous more energy output than you do an input to be able to drive it.
So that's the coefficient of performance, or COP, and
Right.
That's why a heat pump is way more efficient than an electric furnace, like 3 or 4 times more efficient.
Yes.
All right, good. Let's talk about what's involved for homeowners to really do this electrification retrofit. And we're getting lots and lots of calls about that. How can they decide between a ducted unit or a ductless unit?
So this is where I say the average consumer in the United States buys 2.5 HVAC systems in their life. We make good stuff. It lasts a long time, and you normally don't go out in the market and buy a lot of them. When you need it is normally when it stopped working. Normally, people don't think about their HVAC system until it doesn't work. And then what happens is we get this crash course on it. The best thing you can do is have a really good ally in the business. And you should have a relationship with an HVAC contractor or an energy provider or somebody that knows their way around that, somebody that you trust, so that you can bring them into your property, be it your business or your residence, and say, tell me what's going to work best for me. This is how I use my house. I'm going to be here for a while. I'm not going to be here for a while. This is how I want to use it. This is how I see myself using it in the future. And then that comfort consultant, if you will, can work down through a system that's going to make a lot of sense. If you are with efficiency, you buy it up front, right? So more efficient product, you pay more for it. But in the long run, and it doesn't have to be a very long time, you're going to recoup your investment, and then it's starting to be revenue positive after a short period of time. But if you're not going to be in a property for 6 months or a year, then maybe that's not the best investment for you to be able to do. Maybe that investment is something mid-tier in terms of efficiency. So instead of going to 33 SEER, maybe you go to 22 SEER, which is still way above that. So I'm digressing a little bit. The best thing to do is to have a great relationship with an HVAC contractor or somebody in that industry that you understand and trust, and they can come in and make a strong recommendation based on what's there.
All right, good. Makes sense. So, and I guess it also has something to do with the condition of the existing ductwork and the location of the ductwork. So how can homeowners evaluate their ductwork, and what kind of advice are they going to get from that HVAC professional?
A good HVAC contractor can do that. But the basic answer on that is, Barry, are you comfortable? When the HVAC system comes on and goes off, are you comfortable in each and every room of the house? And that is the simplest measure of whether it works or not. Increasing your efficiency on a system that doesn't distribute it well, all that does is make you uncomfortable more efficiently. So making sure that the ductwork is sufficient throughout the property is the job of a HVAC contractor, but it can easily be measured by a consumer is this room comfortable?
And how could the HVAC professional test the ductwork?
Typically, what's used in the industry is what's called a blower door test. We can put hoods over top of grills and registers and diffusers and see airflow measured in CFM, cubic feet per minute, flowing out of there. And based on the CFM, we can determine whether it's sufficient enough for the space that we're in. We can also do a blower door test where we basically block everything off and pressurize it. And if it holds pressure, then the integrity of the ductwork is strong. If it doesn't hold pressure, then we've got some leakage somewhere in the ductwork, whether we can identify it and seal it, or we can make a decision on what the next step is based on the volume of leakage.
You could fix the ductwork. You could replace the ductwork. I just replaced all the rectangular sheet metal ductwork in my house with new tubular ductwork. Or I guess you could put in a ductless system and just abandon all the ductwork. So you got a lot of choices.
Yeah, you can. And that's... again, that's the conversation on what do I want to accomplish while I'm here.
All right, let's talk a little bit about controls. Can I use my existing thermostat? Some people have Nest thermostats. They bought a setback thermostat at Home Depot. Will they work, or do they need a special thermostat?
No, so we have proprietary thermostats. So the answer is you can use a variety of different things. We have proprietary thermostats that are meant to work with our unit. Some are wired, some are wireless, some are to take care of multi-zone systems, and some are to take care of single-zone systems. If you want to use a third-party stat, be it Nest or one of the other ones out there, we do have a thermostat converter, so you can hook any thermostat to our systems. There's some pluses and minuses, but if that's what you really want to do, then that's something that you can do. We also can tie into Wi-Fi, so you can change your temperature anywhere in the world. And then we also tie into a lot of the voice activated devices, Alexa. So if you want to yell out to your Alexa to increase or decrease the temperature in your home, you can do that as well.
Oh, that'd be great for me to have with my kids. It's like, Alexa, tell my daughter to turn her air conditioning down. She's wasting electricity.
Good luck with that.
Yeah, right. Good luck with that. All right. Well, let's talk a little bit about the IRA. How's that affecting demand for heat pumps?
Well, we anticipate that it will affect demand and maintain the demand that's for it. So we know, Barry, that strategic electrification is a strong push in the United States and really has been for some time. We know that it's been part of our national energy policy really since the 70s. So the idea of being able to get off foreign dependence for fuel has always been there. But we also know that through the increase in the technology of heat pumps, that this now is a whole home year-round solution where, quite honestly, 15 years ago, it probably wasn't. Heat pumps didn't perform the way that they perform today. So we know with the Inflation Reduction Act, that really represents a couple of different pieces of legislation. One of the pieces of it, it's what's called 25C, and I know you have some history with that. And really what that is the tax credit. So if you make improvement to your home, you can deduct the sum of money from your taxes. And this has been a piece of legislation that has been out there for some time. And the Inflation Reduction Act continues that, which I think, frankly, is brilliant. And the reason I think that is because a program that is out there that everybody knows and understands and can administer is an easy program to continue to move forward. A second element of that is going to be home energy performance side of it. And that's going to be based off of the income of the consumer. And there's considerable amount of money that's available there for the consumer, both for heat pump technology, for electrical upgrades to the home, for some wiring to be done. So there's thousands, tens of thousands of dollars there based on the income of the homeowner to be able to be applied to heat pump installation. That is a program, the IRA program, take out 25C. The IRA program is being administered by the states. So that was a program that was signed into legislation that came out. The allocations for the funds were, the states were notified of what they were getting, and then they were putting together approved plans to be able to distribute that. And we should see the full impact of the IRA as we start entering into this fall. All of that takes a little bit of time, which is why I like the 25C, because we already knew how to do that. But we should see the full impact of that as the states begin to roll out their individual programs. Probably end of summer, early fall is when we're going to start seeing that. Now, all that being said, there is discussions in Congress now on raising the debt ceiling and making deductions. So some of this is in play. Some of it's been named specifically. A lot of the climate stuff is not everybody's favorite. So today, we expect the IRA Act to continue as is and move forward, and states and everybody's moving forward with it. But just realize that it is being mentioned in the halls of Congress now.
Yeah, you're very diplomatic, Dennis. We'll see how that goes. But boy, it makes a big difference when you look at both the 25C, which is a couple of $1,000 tax credit for heat pumps. That makes a difference. But the bigger IRA rebate provisions that are distributed through the state energy offices, that could cover maybe half the cost of a system, which is really a big deal for a lot of homeowners. All right.
Yeah, and I know we talked about this. I love 25C because what it did is when a consumer, and what it does is when a consumer is out in the marketplace replacing their HVAC system, it doesn't pay for the HVAC system, but what it does, it offsets considerably the cost for them to improve the efficiency of it. So here you have a consumer out in the marketplace that is buying an HVAC system, likely because the one that they have doesn't work anymore. And this is the incentive to go from 14 SEER to 16 SEER or 14 SEER to 20 SEER. It gets the consumer over that hump. to get into a much, much better piece of equipment. And if you look at that, that gives them more disposable income. It's just, to me, it just makes a lot of sense.
Yeah.
A lot of sense.
That's why when we as contractors are advising people to put in, what kind of heat pump, it's like, go for the highest efficiency you can afford. Take advantage of these incentives. You will be grateful for it for as long as you're living in that house.
You're exactly right. And in most cases, because of the incentives that are out there now, it doesn't cost any more, and it could be less expensive to install a more efficient piece of equipment than buying the bare bones basic.
Well, we're almost done. Dennis, tell me how you got into the HVAC business.
So I got in the business like most people get into it. My family was in the business. So I grew up outside of Philadelphia. My father was a manufacturer's representative. My mom did the books in the office. And in the summertime, I made catalogs in the back for a quarter each. I went off to college. I thought I was going to be in the advertising business. And then I took a step back and realized that the HVAC business has been very good to my family. And what I mean by that is that I could make a good living, worked with some really good people, and that's what made it enticing to me. So I was able to secure a job in the business. I didn't work for the family business. At that point, things had changed a little bit, but I came into the business and here I am. Geez, it sounds like a long time. Nearly 35 years later, I'm still in the business. So it's a good place to invest your time and energy in. There's good people in this business, and I like to think that we're trying to do the right thing.
Yeah, you get a lot of happy customers, and they're more comfortable, they're saving money, and they're now able to do the right thing for the environment. That's terrific. Well, how can people get in touch with Fujitsu?
So I would encourage you to take a look at our website, which is fujitsugeneral.com. And on that website, not only are you going to see all the offering of the product we have in both residential and commercial and different styles and different shapes, but there's some great tools on there as well. And some of those tools is we have an eco rebate. So as you enter that, you're able to, it's a little creepy. It geolocates where you are. And then as you work down through it, it tells you every single rebate on every piece of equipment I make based on where you stand. So if you're Philadelphia based, it tells you what PICO is, and it tells you what equipment qualifies for it, and it clicks you directly through on the forms to submit to be able to do it. So if I was a consumer, I would be able to get educated on exactly what piece of equipment I want to be talking about because I know where the breaks are in it. On that website as well, we also have the ability to link to professional to install it. We, like most manufacturers, work in tiers of contractors, if you will. Those that spend more time getting educated on the product and those that install, got the experience of many installations. I want to recommend them before others. That doesn't mean everybody else is not good, but if I'm going to recommend somebody to a consumer or a commercial business, I'm going to recommend the person that's invested the time in training and then also has got quite a few installations under their belt. So FujitsuGeneral.com is where I'd ask your listeners to take a look at.
All right, terrific, Dennis. Boy, I learned a lot on this, and I hope our listeners and viewers of the Energy Show can pick that up also. So that's all the time we have on this week's Energy Show. Thanks, Dennis, for joining us, and thanks to all of our listeners for tuning in. If you missed any of today's show, you can go to our website at energyshow.biz and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.